Problems 1 and 2 on page 434. Doctors have two methods of calculating maximum heart rate. With the first method, maximum heart rate y in beats per minute is this equation, where x is the person's age. Maximum heart rate with the second method is shown in the table. Which method gives the greater maximum heart rate for a 70-year-old? We could simply find the rates of change here. So I'd notice that if we would add one more box here, it would end up with 70 inside. So this is changing by 10, 10, 10, 10, and 10. And this is changing by -7, -7, -7, -7, and if we went here, it'd be -7. So that would be 159. So that would be for this method, for method 2. For method 1, we'd simply plug it in. Y equals 220 minus, we're looking for 70-year-olds, so 70. So y equals 220 minus 70 is 150. So we're comparing this number and 159. So which one has a greater maximum heart rate? That would be the second method. Are heart rate and age proportional or non-proportional for each method? Well, if we look at the first one, if we were to rewrite the first one, let's erase this down here. If we were to rewrite the first one in the form y equals mx plus b, we simply switch the 220 and the negative x. So method 1 would be y equals -x plus 220. So that is non-proportional. Non-proportional for method 1. Method 2, we could create the equation. So slope, our m is -7/10. So plug that in. Y equals -7/10 x. And now pick two variables, or pick coordinates. Let's pick the first one, 20 and 194. So 194 equals -7/10 times 20 over 1. Cancel these, 1/2. So 194 equals -14. No, it doesn't, so we have to add our y-intercept. Add 14 to get it by itself. Add 14, and we get 208. So our equation for method 2, let's write that in here. So method 2's equation is y equals -7/10 x plus 208. And since both of these have b's, neither method shows proportional relationship.